Hey everyone, welcome to this Nekomatata tutorial. This tutorial is an introduction to 3D rigging. If you're new to 3D rigging, then this tutorial is for you. It'll give you the building blocks you need to create this character rig. I'll be explaining what an armature is, what bones are, and what bone parenting is. If you're already familiar with these concepts, you can move on to the next video. For this tutorial series, I'll be using one tool, and that's Blender 3D. It's completely free, so if you don't already have it, hop over to the blender.org website and download a copy for yourself. Let's get started. What is an armature? An armature is also known as a rig or a skeleton. An armature is made up of bones that are used to manipulate a mesh. We can see bones in this armature when we enter edit mode. In edit mode, we can see all of the bones that make up this armature. It doesn't take a lot of bones to make a flexible rig. I'm going to create a new armature and show you how things work. In order to create a new armature, go into Object Mode and press Shift-A. Then select Armature from the drop-down menu. Next, we'll change the name of the armature by going to both the Object tab and the Data tab of the Properties panel. While we're here, let's enable X-ray. X-ray ensures that your armature shows up on top of every other object in the scene. In the Data tab, you'll also see different display options. Currently we're using octahedral. There's also stick, B-bone, envelope, and wire. We'll stick to octahedral. In the same section, there are also options to display the name and axes of each bone. For now, let's keep names on and axes off. Now that you've learned how to create an armature and how to change some important settings, let's get started with bones. Select your armature and then toggle into edit mode by pressing Tab, or by clicking the edit mode button. Here we can take a look at our bone. A bone is made of two parts, a head and a tail. When using octahedral bones, the head and tail are easy to identify. The head is the fat end and the tail is a thin end. A bone uses its head as a pivot point or a point of rotation. The tail is used as a reference point for attaching other bones. Let's explore a few common ways to attach new bones to this armature. The first way is to place your 3D anchor and then press Shift-A in order to add a new bone at that location. The next way is to select a bone and then hold Ctrl and left click. The new bone is attached to the selected bone and its tail is placed where you clicked. It's easy to create a chain of bones this way. The third way to create a bone is by extruding. Select a bone tail and then press E. With this method, you can lock a bone to an axis. This method allows the most control, and I like to use it a lot. There are two more common ways to create new bones. The first way is to press Shift-D to duplicate, and the second way is to press W to subdivide. You can duplicate and subdivide multiple bones at once. This comes in handy sometimes. Now that we have a few bones in the scene, let's explore posing. Currently we are in edit mode. Edit mode is used for setting up the original skeleton hierarchy. We can only add and change the original positions of bones in edit mode. We're going to go into pose mode. Pose mode is used for posing your armature. It's also the mode that's used for animating and testing out your rig. Create a pose by selecting a bone and pressing G to grab, R to rotate, or S to scale. In pose mode, you can reset bones to their original position, location, and scale. by selecting the bones and pressing Alt-G, Alt-R, and Alt-S. You may notice that sometimes when I move a bone, other bones move along with it. This is because bones work in a hierarchy. Some bones tell other bones what to do. I'll be going over bone hierarchy and bone relationships next. When a bone has another bone attached to it, the bone is considered a parent. The attached bone is a child. A parent bone tells its immediate children how to behave. When a parent bone moves, its children move along with it. A bone can be both a child and a parent at the same time. Let's create a chain of 3 bones to demonstrate this concept. Create 3 bones by extruding, and then name the bones arm, hand, and finger. After creating and naming the 3 bones, if you go into the Properties panel, under the Bones tab, you'll see that hand's parent is arm and finger's parent is hand. This is to demonstrate that hand can be a child to arm and a parent to finger at the same time. When I rotate the arm bone in pose mode, the hand bone moves with it. The finger bone also moves because hand is its parent. A bone can also have multiple children. Let's extrude 4 more bones out of the hand bone. These bones are children of the hand bone. And now we have a full hand of 5 fingers. When the hand moves or rotates, the finger bones move and rotate along with it. The finger bones can also rotate independently. They are only influenced by the movement, rotation, and scale of the parent, and do not affect each other. These are the basic rules of parent-child bone relationships. Sometimes a child can break the rules and not listen to some of the influences of a parent. Let's look at some of those settings. Select the hand bone and navigate to the Properties panel Bone tab. Find the section that says Relations. Under the Parent box, you'll see some checkboxes that say Connected, Inherit Rotation, and Inherit Scale. Uncheck Inherit Rotation, and let's see what it does. When I rotate the arm bone, the hand bone doesn't rotate along with it. It keeps its own rotation and ignores the parent rotation. In our final rig, this is used in the arms. This keeps the arms stable even when the upper torso is moving. It's also a setting that's used in the head and the chest bones. This single setting can greatly improve the usability of your rig. The same effect applies when you disable Inherit Scale, although I haven't found many uses for it. Just keep the possibility in mind. The last thing you'll need to learn is how to assign a parent bone, how to clear a parent bone, and the difference between a connected parent bone and an offset parent bone. There are 2 different ways to assign a parent to a bone. The first way is to select the bone and assign its parent in the Bone tab of the Properties panel. The second, easier and faster way is to select the bone and then select its parent. Press Ctrl P and select either Connected or Keep Offset. Using this shortcut allows you to assign a parent to multiple bones at once. Select all of the bones that you would like to assign, and then select the parent bone. Press Ctrl P and pick an option. You can clear the parent of a bone by pressing Alt P. You can clear the parent for multiple bones at once. So what's the difference between a connected bone and an offset bone? Basically, when a child bone is connected to its parent, it can only rotate freely. When the relation is set to offset, the child is able to change its location in relation to the parent. This means that the child can move freely and rotate freely. The child bone only gets a little bit of freedom though, because if the parent bone moves or rotates, the child bone will still move and rotate along with it. One scenario where keep offset might come in handy is if your character was wearing a hat. Let's say they're running fast and the hat needs to bounce up and down. The hat is able to move freely and bounce off of the head while also following the rotation and location of the head bone. This setting is also commonly used in free moving joints like the shoulders, fingers, and thumbs. Connected bones are usually used in joints that need to stay connected, like your knees, elbows, or neck, unless your character is getting its head chopped off, which in that case you'd use an offset relation. Well, that's it for this video. Have fun experimenting and making new rigs. In the next video, we'll be going over forward versus inverse kinematics. It's a lot easier than it sounds. Thanks for watching. Peace!